just a second. So what you would have is two columns. One of them is going to be listed as low, and the second one will be listed as high. So did you do a lower concentration of Taxol and a higher concentration of Taxol, right?
Well, yes.
Yes. And I know saffron is going to be an outlier in there, so we are just going to try to make it easy first.
Okay.
So, and then your three categories, so low versus high is your first variable, the concentration of the drug. Well, it's actually a second variable. And the first variable is going to be the drug itself. So in this case, the first thing you would write is, now go to column Q and write, yeah. So don't write there, move one down, actually move two down and write untreated. And then select, how many do you have? Three numbers, right?
Mm-hmm.
So select three cells, one above and one below that untreated, right?
Okay.
So select Q13 through 15.
Like this?
Yes. And do merge and center. Now that merge and center thing is not necessary. It's more just my OCD.
Okay.
And then go to the top, continuing with my OCD. Go back to that top toolbar. And you know how you centered it? Go above it and center. Yeah, there. See, so
I've
much.
been trying to figure out how to do that. So perfect.
Yeah, so now copy paste that twice underneath. Control C, Control V, Control V, there. And now we're, yeah, for the second one, write BM, Taxol,
Just Taxol.
just Taxol.
Okay.
And the second one, write BM. So for now, we're going to keep saffron out of the equation. For this particular two-way ANOVA, what you're going to have is basically one variable is presence, what drug they're being treated with. And the second variable is whether it is low or high.
Okay. So
Concentration. So the amount of drug and the type of drug. Those are your two variables.
Okay.
Understood? Okay.
Yeah.
So now you are going to go ahead and copy those values into each one of those categories. Now, obviously for untreated, there is no low versus high. It's going to be the same exact numbers in both columns.
Okay. Perfect.
Okay. So you're just going to copy paste those numbers in each of those columns. Oh no, that's not Control Z.
Trying to.
Control Z. There.
And then Taxol.
And then that's your high. And then the 6 microliter one is your low. Also remember, when you go to write your report and to make your graphs, either label them as Taxol low, Taxol high, or but anytime you talk about them, you're going to mention the actual working concentration of the drug. The volume has absolutely no meaning.
Okay.
That's something multiple students are making issues with.
Okay.
I don't know if that's a good thing. I have work to do.
All right.
Okay, perfect. So now you've got it in the right orientation. So for a two-way ANOVA to, be recognized by Excel, it has to recognize the different variables.
Okay.
And that's why we have to put one of the variable in columns and one in the rows.
Okay, that
So
makes
this way now you can very clearly see, and Excel can very clearly see low versus high as one variable, the concentration that is, and then the presence or absence of drug as the second. Now go to your data analysis tab. Yes, and do the two factor with replication. Since we have equal number of replicates, we can do that. And you are going to select that entire table that you just made, including the labels.
Okay.
Yeah, there you go. And then you are going, there are 3 rows per sample, everything else is fine. Select where you want your results. Don't put them there. Can you put them below
Yeah.
where we can see it very easily?
Yeah.
Sure. Okay. There you go. So now the first 4 tables are just about the samples, right? So the first one is a summary of low versus high, that first variable. The second one and the third one are each of your, or the next 3, these are each one of your treatments. So for each of your treatment sample, there is a low versus high. And that's the averages, variance, all that good stuff, right? And that's what you're going to be looking at to decide whether to run the equal variance or unequal variance, right?
Yeah.
And clearly it's unequal variance because it's all over the place.
Yeah. Okay.
Now, the only one that you care about right now is down here at the very bottom where it says ANOVA. So can you move it up so it's, and maybe expand it a little so we can see it better? Bigger. There you go. A little bit more big. So just press on that plus. Yeah, there you go. Perfect. Now, this has 3 p-values. It didn't just give you 1 p-value, right? So first of all, this still has to take into account Bonferroni equation, right? So now this time you have to look at all the different combinations that can be happening. So you have your 3 treatments here, right? The untreated black mulberry and Taxol, and then low versus high. And looking at all those different groups, you actually have 5 different groups to look at, right? Because untreated is duplicated essentially. So you have 5 different groups. So your Bonferroni correction is going to take into account all of those.
Okay.
So it's going to be a really, really stringent one, right? It's going to be the total number of groups minus 1 because untreated doesn't count. So it's 0.05 divided by 4. Okay.
Okay.
So what's the acceptable p-value in that case?
It's anything below 0.05, right?
Nope, not here. Because with the Bonferroni correction, it's going to be 0.05 divided by 4, so it's 0.0125.
Okay.
Okay.
All right.
So now you have 3 different p-values to look at. The first one is to look at the p-value for sample. Is that below 0.0125?
Yes.
Yes, so that's significant and you can highlight it.
Okay.
Okay. That one is going to be looking at the different treatments. So it is saying that somewhere in there, one or more of the treatments are behaving differently than the others. That's all. Doesn't tell you which one.
Okay.
Second one is columns. Is that below 0.0125?
Yes.
Yep, again. And this one is telling you that somewhere in the treatments, when you compare low versus high, one or more of the drugs are behaving differently at lower versus higher concentration.
Okay.
The last one is interaction. And this one says 0.0215. Is that significant?
Yes.
Is it below
Yeah,
0.0125?
never mind.
No, it's not.
Yeah.
So this one actually in this case is not significant because of the number of groups you have. And because it's, once Bonferroni correction is taken into account, it's not below or equal to 0.0125.
Okay.
However, this interaction tells you whether or not your 2 drugs behave same or different. So if Taxol killed the cells and black mulberry killed the cells, then you wouldn't expect this difference, any significant difference, and that's what you would see.
Okay, so that's
If
good.
Taxol killed the cells at 50% and black mulberry killed it at 20%, you would expect to see a difference here.
Okay.
Or if Taxol killed the cells and black mulberry grew the cells, then you wouldn't expect to see a difference either.
All right.
So the only time you would see a difference, or then you would see a difference as well, actually, sorry. The only time you would see a difference is if those 2 drugs either behave in opposite manner or one behaves significantly better than the other.
Okay.
right now, based on Bonferroni correction, both drugs work, the same.
Okay. So that was,
Understood?
yeah.
Now, this is very close to 0.0125. So, it's not like 0.135 or anything. So it's still, you're going to find differences when you do individual t-tests. Now you have to run the t-tests.
Okay.
This time it's going to be a lot more t-tests. So let's go up back to your chart and we can look at all the t-tests you need to run.
All right.
So you are going to be, first of all, write sample, just so we can make a clear indication of which ones we are comparing. So write sample. When we are looking to confirm which sample is different, which treatment is different, you are going to be doing all the treatment comparisons. So you would be doing untreated with Taxol low, untreated with Taxol high, untreated with Black Mulberry low,
Okay.
untreated with Black Mulberry high,
So I put
right?
all under sample.
So sample is basically untreated with Taxol, untreated with Black Mulberry, and Taxol with Black Mulberry. But what you're going to have are individual columns right now,
Okay.
right? So it's going to be untreated with Taxol low, untreated with Black Mulberry low, and then Taxol low with Black Mulberry low. So you're staying within the same column, but you're comparing the treatments. Then you'll do the same 3 for the high.
Okay.
Untreated with Taxol high, untreated with Black Mulberry high, and Taxol with Black Mulberry high. Taxol high with Black Mulberry high.
Okay. Text.
To compare in your columns, yeah,
And then
and then Black Mulberry, Taxol high with Black Mulberry high. Yeah. So to compare your columns to see whether low and high makes a difference, you are going to be doing Taxol low versus Taxol high, and Black Mulberry low versus Black Mulberry high.
okay. And is this we're running the t-test the same way we did last time?
Yep, same
Okay.
thing.
Perfect.
So that's going to be your column. And then the third one is going to be the interaction. Now in interaction, actually, one of the ones in there is in a way your Taxol versus Black Mulberry as well. But the real interaction would be Taxol low versus Black Mulberry high, and Taxol high versus Black Mulberry low. Those two would be the additional ones.
The additional ones that I add to these sample.
No, these are not sample. Those will be under interaction. So
Okay.
the sample ones you already listed, right? The 6 that you have under sample. And in between, write the columns first. How about the column one? Go up a little bit.
Yeah.
Yeah,
Where?
write column.
Sorry.
Column, which is the second variable, low versus high. No. Right here, where the green column, green square is, write column, COLUMN. You're comparing your second variable, yes. And under column, you will have Taxol low versus Taxol high, and Black Mulberry low versus Black Mulberry high.
Okay.
And then in your interaction, it's gonna be Taxol low versus Black Mulberry high, and Taxol high versus Black Mulberry low.
Perfect.
Okay.
All right. And then, all right.
So
Sweet.
in all, in this, you will have 11,
Yeah, 11 t-tests.
10 or 11 t-tests.
Okay.
Okay.
Well, sweet. Thank you very much.
So now remember, you kept the saffron out of the equation because that didn't fit into your two-way ANOVA scenario, since you didn't have 2 different concentration of saffron. So you still have to run those t-tests too if you're going to include it into your conclusions.
Okay,
Okay.
perfect.